Hello. Today we're going to look at scientific notation, and we kind of tucked this in because we just got done talking a lot about decimals, and when you deal with scientific notation, it's all about where you put your decimal place. So looking at this first problem, we're going to take some numbers that are in scientific notation and switch them back to like their normal format, a standard notation. So looking at this first one, it says write 9.978 times 10 to the 6th. We are looking at this 6 right here, that exponent, times 10 to the 6th power. 10 to the 6th power is 10 times 10 times 10 times 10, 6 times, all right? Now, if I were to multiply something by 10, all it really does is it moves a decimal place to the right one place. If I take 7 times 10, now it's 70. Okay. What this exponent does is it tells me how many places to the right I'm going to move my decimal. So on this first problem, it's 9.978, but I'm going to move, since I'm multiplying by 10 6 times, I'm going to multiply that decimal 1, 2, 3, and then I'm going to have to go 4, 5, 6. I'm going to have to add in 3 extra zeros there. So this number is actually 9,978, and then add 3 zeros in there. All right, if you have this next problem where your exponent is negative, what that's telling you to do is actually you're dividing by 10 is ultimately what's happening there. Instead of moving your decimal to the right, you're going to move your decimal to the left. So positive exponents go to the right, and that exponent is that number up there. Negative exponents, you would move your decimal left. So in this case, I have to move it to the left 8 times. So I would move it to there. That's 1 time. But then I would have to keep going a whole bunch of times. I'm going to run out of room. But ultimately, I've got to back it up 8 spaces. Since I only backed it up 1 to get in front of the 3, I've got to put in 7 zeros in there. So 1, 2, 3, 4, 5, 6, 7. And then the 3, 8, 3, 9. And you can see here then that the decimal was there, but I moved it 1, 2, 3, 4, 5, 6, 7, 8. And that's why it ended up there. Okay. This right here. Oops, sorry, lost that 9. There's your answer. Now we're going to try doing some problems that start off in standard notation, and we're going to switch them back to the scientific notation. To write a number in scientific notation, the first portion of that always has to be a number somewhere between 1 and 10. So when I look at this 71 million number that I've got going, I have to decide where to put the decimal so that my number is going to be between 1 and 10. And in this case, that means I want to put it right there. So it's like a 7.18. That would be a number between 1 and 10. I'm going to put my decimal right here. And I'm going to put as many digits that aren't 0, and I'm going to go ahead and write those out. And then it's times 10 to the, and now ultimately what I'm trying to do is get this number up here. So I'm going to look at that decimal that I just stuck there and see how many places did I move to the right to get that. So there's 1, 2, 3, 4, 5, 6. I have to move it 7 places to the right. So I'll put a 7 there. This next number you can see is a decimal number that's very, very small. So that means I'm going to be moving my decimal to the left, which means I'm going to have a negative exponent. So looking at all the digits there, I pick out where I can put my decimal so that it's a number between 1 and 10. I see it as right here, 4.65. That would fall between between 1 and 10. All right, times 10 to the, now let's look at this. If I put my decimal here between the 4 and the 6, to get it where it needs to go, it has to go left 1, 2, 3 places to the left. That means I'm going to put in a negative 3 for my exponent. There's your answer. My last example here deals with just a number 1 because they did put this in there several times in your homework. So if you have just a 1, you have to think of that as like just a decimal right here, like a 1.0 or something like that. If you just have a single digit there, the decimal is after that number. So think of it as right here. And then times 10 to the 5th power, the positive 5 tells me to move my decimal 5 places to the right. 1, and then I would go 1, 2, 3, 4, 5, which is going to ultimately add 5 zeros to this number. That number is actually 100,000 then. If your decimal is back here, that means it's smaller numbers, so you're going to be using a negative exponent. I still want that number or that decimal to be right here so that it's just a 1 times 10, and then if I put that decimal there, I would have to back it up 3 places to make it land there. I'd end up with a negative 3 for an exponent. All right, that's all I've got for you. Hope this helps.